What happens when you redesign an aircraft carrier from the keel up? You get the USS Gerald R. Ford, CVN-78, the most advanced warship in history, engineered to project American power across the oceans for the next half-century. The opening scene unfolds at dawn. Aerial cameras sweep across the horizon as the Gerald R. Ford cuts through calm seas, its massive flight deck stirring with precision. Sailors move like clockwork, fighters roll into position, and the carrier comes alive. The soundtrack builds, waves crashing, engines roaring, horns echoing, a perfect overture for this floating fortress. Voiceover. Bigger, smarter, faster, not just another carrier, but a floating city of steel, designed to launch more sorties, fight tougher battles, and host the weapons of tomorrow. From electromagnetic catapults to next-generation nuclear reactors, every part of the Gerald R. Ford reflects innovation, ambition, and unmatched naval power. Today, on WarTech World, we take you inside CVN-78, the systems, the sacrifices, and the strategy that make this ship a game-changer. The scene cuts to a rapid-fire montage, jets hurled skyward by EMALS, crew coordinating from the futuristic island control tower, advanced elevators carrying munitions with breathtaking speed, and the low hum of nuclear reactors beneath the decks. Then the screen fades to black, text appearing in bold. USS Gerald R. Ford, the future of carrier power. History and development. To understand the story of the USS Gerald R. Ford, we need to step back to the years after the Cold War. The United States Navy emerged as the undisputed global sea power, but its carriers, especially the Nimitz class, first launched in the 1970s, were showing their age. These giants had carried American aircraft into every major conflict from the Persian Gulf to the Balkans, but by the late 20th century, the demands of warfare had changed. Precision weapons, faster operations, and emerging threats from advanced missiles meant the Navy needed a carrier designed not just for today, but for the next 50 years. The answer was CVN-78, the lead ship of a brand new class. From the outset, it was clear that this would not be a simple upgrade of the Nimitz. The Gerald R. Ford program was conceived as a generational leap forward. Lessons learned from decades of carrier operations informed every design choice. The Navy asked for more electrical power to support future technologies like directed energy weapons, a flight deck that could generate significantly more sorties per day, and systems that would reduce crew requirements, saving billions in manpower costs over the ship's lifetime. Construction began at Newport News Shipbuilding, the only yard in America capable of building nuclear-powered carriers. Huntington Ingalls and Northrop Grumman led the effort, with thousands of engineers and shipbuilders tasked with designing a carrier unlike anything before it. The keel was laid in the mid-2000s, marking the start of a massive industrial project that employed tens of thousands of Americans across the defense sector. But innovation never comes cheap. The Ford program faced cost overruns, delays, and intense political scrutiny. Each of its revolutionary systems, EMALS electromagnetic catapults, the advanced arresting gear, and modernized weapons elevators, required years of testing and refinement. Congressional hearings often questioned whether the Navy's carrier of the future had become too ambitious. Yet history shows us that every major naval revolution, from the transition to steam power to the first nuclear carriers, faced the same skepticism. Sea trials eventually proved the concept. Despite teething problems, CVN-78 pushed forward and was formally commissioned in the mid-2010s. She became the first of a new class intended to replace the Nimitz carriers one by one, ensuring that America's Navy could project power well into the 21st century. As one naval historian put it, in many ways, the Gerald R. Ford is the Navy's bet on tomorrow, expensive, controversial, but engineered to remain relevant for decades. The ship's story is not just about steel and technology. It is also about strategic foresight, an acknowledgement that naval warfare is evolving, and that the United States must evolve with it. The Gerald R. Ford embodies that gamble, building today for the uncertain wars of tomorrow. Specifications and technology. At first glance, the USS Gerald R. Ford, CVN-78, looks like any other American supercarrier, a vast, flat flight deck, a towering island, and the unmistakable silhouette of naval dominance. But beneath that familiar shape lies a revolutionary design. The Ford class is not just an evolution of the Nimitz, it is a ground-up rethinking of how a carrier should generate power, launch aircraft, and sustain operations in the 21st century. The foundation begins with power and propulsion. Like its predecessors, the Ford is nuclear-powered, but its next-generation reactors deliver almost 3 times the electrical output of the Nimitz class. That surplus is not an accident. It is a deliberate investment in the future, power not only for today's radar and catapults but also for tomorrow's energy-hungry systems like lasers, high-power sensors, and potentially even electromagnetic railguns. In other words, the Ford was designed with decades of growth built into its core. Perhaps the most famous innovation is EMALS, the Electromagnetic Aircraft Launch System. For more than 60 years, carriers relied on steam catapults, powerful but mechanically brutal. EMALS uses linear induction motors to hurl aircraft into the sky with smooth, precisely controlled acceleration. The benefits are enormous: reduced stress on airframes, the ability to launch lighter unmanned aerial vehicles, and a wider range of aircraft types. It's a quieter revolution, literally, but one that fundamentally changes how carriers send their aircraft into combat. Just as important is the Advanced Arresting Gear, AAG. Landing on a carrier has always been one of aviation's most dangerous feats. AAG replaces older hydraulic arresting systems with energy-absorbing electric motors and digital controls. It allows for finer adjustments, safer recovery of lighter drones alongside heavy jets, and easier long-term maintenance. Together, EMALS and AAG define the Ford's flight deck as a bridge between the manned fighter era and the unmanned future. The flight deck itself has been completely reimagined. Aircraft can be spotted, armed, launched, and recovered more efficiently thanks to a new deck layout and restructured island placement. The result is a dramatic increase in sortie generation rate, the very measure of a carrier's combat endurance. In wartime, that means more jets in the air, more often, and more pressure on the adversary. Beneath the deck, the Ford introduces advanced weapons handling systems and elevators. These magnetic, rail-driven elevators can lift thousands of pounds of munitions directly from secure magazines to the deck in seconds. They are faster, safer, and require fewer sailors to operate. In combat, this speed translates to more bombs on wings and fewer bottlenecks in the most critical moments. Supporting all this are new sensors, combat systems, and survivability features. The Ford's command and control architecture integrates cutting-edge radars and defensive systems, improving battle management in complex environments. Redundant designs and automated controls reduce crew workload, allowing the Navy to cut down the overall crew size compared to a Nimitz, a crucial factor when lifetime personnel costs run into the billions. Finally, what sets the Ford apart is its future-ready architecture. More than any single system, it is the integration of power, automation, weapons handling, and aviation support that defines this ship. It is a carrier built not just for F-35s and Super Hornets but for aircraft, drones, and weapons systems that have not yet been invented. As one naval engineer put it, this isn't about a single system. It's about a carrier that was redesigned from stem to stern, power, launch, recovery, weapons flow, and command and control, all re-engineered for the wars we haven't fought yet. Operational role and performance. The USS Gerald R. Ford, CVN-78, may look like her predecessors from afar, but her operational role reflects a new vision for American naval power. She remains the centerpiece of the Carrier Strike Group, the beating heart that projects air power, ensures sea control, and responds to crises anywhere on the globe. What has changed is how she does it. At the core is the air-wing integration. The Ford's deck is designed to support the F-35C Lightning II, the stealth fighter that redefines carrier aviation. Alongside the F-35C operate the Trident True F divided by a -18E divided by F Super Hornets, the electronic warfare specialists EA-18G Growlers, and the E-2D Advanced Hawkeyes, which extend radar coverage and command and control deep into the battle space. Helicopters provide anti-submarine, logistics, and search and rescue functions. Looking forward, the Ford is built to accommodate unmanned aerial vehicles, from aerial refueling drones like the MQ-25 Stingray to future combat UAVs. This seamless integration ensures that the carrier's air wing is both lethal today and adaptable tomorrow. The Ford sortie generation rate is what truly sets her apart. Sortie rate is the measure of how many aircraft a carrier can launch and recover over time. In combat, this number defines everything: the ability to maintain air superiority, to keep constant pressure on enemy defenses, to provide close air support for troops ashore. Thanks to her redesigned deck layout, advanced elevators, and EMALS launch system, the Ford promises significantly higher sortie output than the Nimitz class, more jets in the sky, more often, with fewer delays. In modern warfare, tempo is survival, and Ford was engineered for tempo. Sustaining that tempo requires robust underway logistics. The Gerald R. Ford is not just a ship, it is a sovereign base at sea. With nuclear propulsion, she can remain deployed for decades without refueling her reactors. Replenishment at sea brings food, munitions, and aviation fuel, allowing her to operate continuously far from U.S. shores. Her advanced systems and streamlined maintenance cycles reduce downtime, ensuring that America can keep a carrier strike group forward deployed where it matters most, whether in the Pacific, the Mediterranean, or the Persian Gulf. Of course, no revolutionary system comes without its challenges. During tests and trials, both EMALS and the advanced arresting gear experienced reliability issues. Launches were interrupted, recoveries had to be refined, and critics questioned whether the new technology was ready. But this is the reality of naval innovation: every leap forward comes with a learning curve. Iterative fixes and operational feedback have steadily increased reliability, and each deployment adds to the Navy's confidence that the systems are performing as designed. Finally, the Gerald R. Ford is more than a flight deck. She is a command and control hub, an afloat headquarters linking aircraft, escorts, submarines, and even distant land-based forces into a single battlespace network. In the 21st century, information is as vital as firepower. With advanced combat systems and data networks, the Ford acts as a nerve center, orchestrating joint operations across the sea, air, and cyber domains. As one naval officer put it, the carrier still wins fights by generating sorties. The Ford's promise is to generate more sorties, with fewer sailors, and in ways that keep us ahead of the fight. Expert analysis. When evaluating the USS Gerald R. Ford, analysts tend to divide their judgments into two categories: the undeniable strengths that define her as a leap forward, and the risks that come with building the most ambitious warship ever constructed. Let's start with the strengths. The most frequently cited advantage is the Ford sortie generation potential.
The new propulsion system
By
will allow for
redesigning the
greater
deck,
efficiency.
modernizing
We'll need to
elevators,
reevaluate the energy
and
output.
replacing steam
Yes,
with
and consider the weight
electromagnetic launch
distribution as
systems, the Ford can theoretically field far more aircraft in a 24-hour period than any carrier before her. In war, that number isn't just a statistic, it's the very measure of sustained pressure. The ability to launch wave after wave of fighters and bombers is what makes a carrier a strategic weapon, not just a ship. Closely tied to that is the ship's electrical power capacity. With nuclear reactors capable of producing nearly 3 times the energy of the Nimitz class, the Ford is not only powering her own systems but also reserving vast capacity for tomorrow's weapons. Directed energy lasers, electromagnetic railguns, and high-power sensors, all of these are on the horizon, and the Ford is designed to host them without major redesigns. Then there's crew efficiency. Through automation, streamlined workflows, and smarter systems, the Ford is able to operate with hundreds fewer sailors than a Nimitz-class ship. Over a 50-year service life, that reduction represents billions saved in salaries, training, and support costs. And beyond money, a smaller crew means more efficient living conditions, improved ergonomics, and better quality of life for the sailors on board. Finally, the Ford is deliberately built as a flexible platform. The design is future-proofed not just for manned fighters, but also for unmanned systems and new payloads that haven't yet entered service. In other words, the Ford can adapt, and adaptability is often the true key to longevity. But every strength comes with risks. The first is cost. With procurement costs exceeding $13 billion per ship, and lifetime costs far higher, the Ford class is the most expensive warship ever built. Critics question whether the Navy is buying too much capability in a single hull, and whether those resources might be better distributed across a larger fleet of smaller, more survivable vessels. Second, the Ford's cutting-edge technologies come with testing and maintenance challenges. EMALS, AAG, and weapons elevators all suffered teething problems, leading some to argue that the Navy was too ambitious, too soon. Reliability is improving, but the systems demand new maintenance regimes, training, and supply chains, a learning curve that cannot be ignored. Finally, there is the issue of scale and vulnerability. A carrier is a visible, high-value target. In an era of hypersonic missiles, long-range precision fires, and sophisticated anti-access/area denial, A2/AD, networks, some analysts worry that carriers may be at greater risk than ever before. The Ford's survivability increasingly depends not on her armor, but on the layered defenses of the entire strike group, destroyers, cruisers, submarines, and aircraft that form her protective shield.
We have an incoming.
This leads to the strategic trade-offs. The Ford is as much a political instrument as it is a military one. When a Ford-class carrier sails into a region, it projects not just power, but presence, deterrence, and alliance assurance. It tells friends and adversaries alike, America is here, and America has options. At the same time, its vulnerability to A2/AD challenges has forced the Navy to evolve tactics, dispersing assets, integrating unmanned systems, and operating as part of a distributed, networked force. Or, as one analyst put it succinctly, is the Ford an insurance policy for U.S. power? Yes. But it's not a silver bullet. It creates options, not certainty. Impact and future. The story of the USS Gerald R. Ford is not only about technology, it is about the future of American sea power and how naval warfare will evolve in the decades ahead. More than any ship afloat today, the Ford embodies the intersection of strategy, diplomacy, and industrial might.
We have unusual energy
First, there is the matter of alliance and diplomacy. When a Ford-class carrier enters a theater, whether the Mediterranean, the Western Pacific, or the Persian Gulf, it changes the strategic equation instantly. Allies see reassurance, adversaries see deterrence. Carriers are not just tools of war, but tools of statecraft. Their presence enables joint exercises with NATO, strengthens security guarantees in Asia, and signals to rivals that American power is both credible and enduring. For partners who cannot build such ships themselves, the Ford is a reminder of why alliances matter. Next comes the technology pathway. The Ford was designed with extraordinary margins of electrical power and cooling capacity. These aren't luxuries, they are foundations for the future. Directed energy weapons that can shoot down missiles, advanced electronic warfare systems that dominate the spectrum, high-power radars that extend detection ranges, all of these are energy hungry. The Ford is not just able to host them, it was built for them. In this sense, the carrier is less a finished product and more a platform, a launch pad for technologies that will define the next era of naval combat. Then there is the integration of unmanned systems. The Navy's MQ-25 Stingray refueling drone is only the beginning. Future unmanned combat aircraft could fly strike missions, reconnaissance sorties, or even electronic attack runs, operating alongside manned fighters. The Ford's flight deck, EMALS, and AAG were designed with this in mind. As the balance between manned and unmanned aviation shifts, the Ford is prepared to adapt. This flexibility ensures her relevance not just in today's battles, but in tomorrow's. Another dimension is the budget and industrial base. The Ford-class program sustains America's sole nuclear carrier shipyard at Newport News, along with thousands of suppliers and tens of thousands of skilled workers. This industrial base is itself a strategic asset. It preserves design expertise, keeps supply chains alive, and ensures that the U.S. can continue building and maintaining the world's most complex warships. In a geopolitical contest where industrial capacity is as decisive as weaponry, the Ford is as much about sustaining a national ecosystem as it is about deploying a ship. Finally, the Ford points toward an evolving doctrine. The Navy is already shifting toward concepts like distributed lethality, where power is spread across many platforms, electromagnetic spectrum warfare, where the battle is fought in data and signals, and dispersed strike, where carriers operate with greater unpredictability. The Ford, with her power reserves, automation, and design for integration, makes these doctrines possible. But a question remains: can one ship class remain dominant in a world of hypersonic weapons, anti-access belts, and unmanned swarms? The answer is not certainty but choice. The Ford does not guarantee dominance, she guarantees options. And in strategy, options are everything. As one analyst concluded, the Gerald R. Ford buys time, and time is the most valuable currency in future warfare. Conclusion. As the sun sets over the horizon, the USS Gerald R. Ford stands silhouetted against the waves. Fighters return from their sorties, deck crews form ranks, and the carrier herself seems to embody both legacy and future. The Gerald R. Ford is not perfect. No warship of this scale ever is. But she represents an audacious gamble, a vessel built not for yesterday's battles, but for tomorrow's wars.
The new propulsion
With unmatched power reserves, revolutionary launch systems, and the capacity to host weapons that haven't even been invented yet, Ford is both promise and challenge. For the United States, its sailors, and its allies, she is a symbol of resilience, a bet on the future of naval dominance. So we ask you, is the Ford a true revolution in naval warfare, or an unaffordable luxury? Your thoughts matter, drop them in the comments. If you enjoyed this deep dive, hit that like button, subscribe to WarTech World, and ring the bell so you don't miss our next breakdown of cutting-edge military technology. Share this video with a friend who loves naval history and modern warfare. It helps us grow this community of defense enthusiasts. Next time on WarTech World, Avant-Garde Hypersonic Glide Vehicle. Don't miss it.